Hello there, welcome back. It's me again. Now, I want to continue on with what we were discussing, but in the meantime, or prior to continuing, I want to go over something that I mentioned in the last video and that I haven't yet explained. It is part of a C++ language thing, and I haven't mentioned it for sort of I wouldn't say a personal reason, but a specific reason that arises due to my personality. And that is this idea of virtual derivation. That is, to derive one class derives from another class using the keyword virtual in front. But what does that mean? That is, you saw before. You can see in this server thing here several instances. Wrong file. Here. Public virtual something, right? So that's that one, and this one too has the same thing. No. Another one has the same thing. Public. That's just this thing. It's gotta be one of these two. Let's see that one. Oh, okay, they're both in the same file. Okay, and it's no coincidence that the virtual keyword here is occurring in front of the same object that's being derived from. Okay. Now, I don't want to go into too much detail, but if you go online and look up virtual derivation or something, or inheritance. Oh, here we go. Now you can tell immediately in just the blurb here. We already checked to see what the example was. This example is given by Björn Strostrup, or I don't know how you pronounce that, Strostrup, the creator of C++. I think he actually believes that himself. I don't, and he shouldn't. It's true that he maybe started the initial work on it, but to say that one person, Björn Strostrup, created or invented C++ would be like saying that James Watt invented the steam engine, right? It doesn't work like that. In history, it's true. James Watt, in a sense, invented the steam engine, but really, the engine that he so-called invented was invented by another person called Newcomen, and Watt was repairing that engine, and by sheer accident, apparently, he realized how to significantly increase the efficiency of that engine using a kind of condenser, using the condensing mechanism they used ever since. You might say that James Watt started the Industrial Revolution, but that's not true either. That was many people involved in that. But okay, Strostrup has an example. An example. This isn't the one of his, but it's exactly the same idea. want to see his example, you can see it too. But here's an example. Okay, let's copy this. Now this seems like straightforward C, C++, stuff we're used to. I'm all ready with my put func. I wanted to download that because there's something mentioned about James Watt in there. Okay, now I can't read it like this, and so they say. Just have it. I know you probably prefer it the way it is, but I have trouble reading it that way. Okay, this is the format I can read and understand it in. Alright, now it turns out actually this virtual here is not a problem. This keyword, we can get rid of this and we still have a problem. In fact, we can get rid of all these virtuals and we still got a problem. Okay. Let's put my bat here. Alright. Well, let's just see if this compiles. Can I make one? I don't know if you've already noticed the problem. I must have changed that. This does seem kind of natural. Okay, you have animals eat, that's true. A mammal's an animal, okay. And a mammal is an animal that breathes, true. A wing animal is an animal with flaps its wings, okay. It's compiling, okay. Let's see now what we can do, since our bat is a winged mammal, is we can make our bat breathe, eat, or flap. Let's see the breathing. Can it breathe? The answer is, you can probably guess, completely unambiguously, yes. And of course we haven't implemented breathe, but that's no problem. I'll put that everywhere. I don't know why they give these examples. They have to use virtual everywhere else. When they're talking about something, virtual inheritance, right? And they put virtual everywhere, and it makes you think that the virtual has something to do with that, but it doesn't. Okay, can our bat flap its wings? The answer should be yes. Let me try to make the bat eat. There are two questions. A, is it going to compile? And B, if it does compile, what does it mean? Okay, now we got a problem. Ambiguous access to eat. It could be, animal, eat, or it could be from animal. What do you mean? It could be animal, it could be animal. It's both. It's animal and it's eat. So what's your problem? There's no ambiguity, right? Well, there is an ambiguity. Because if you look at this class bat, right? If you could draw a picture, first you've got mammal, which I think on M, and winged animal. So let's call this mammal. Winged animal and mammal. Now, mammal is an animal, right? And winged animal is also obviously an animal. Okay, no problem. And now we have a mammal, which is a winged animal. Dot. And that's our object here, our bat. Okay, so now the bat is a winged animal, which means that it's an animal. So this section of the bat contains an animal element. This section of the bat also contains an animal element. So we got two animals when really there should only be one animal, right? There's only one bat animal. Somehow this animal and this animal have to represent the same thing, but they don't because of the way inheritance works. If you recall, multiple inheritance, the way the memory is laid out is you have class 1, we would have animal, it's going to be one way or the other, mammal, and then animal again, and then winged animal, and then that's our bat, right? Bat. Okay, so there are two copies of animal. If they're virtual functions, it gets even more complicated. But the problem again is that there should only be one animal. And the way to solve that, according to the C spec, is what you do is you put the keyword virtual here. And what that does is that takes this animal and does what you want it to do. Gets rid of that line. And this becomes one of these things. Don't need a dot in this case. Did I in this case? I did. That's weird. Because I should have gone one further over. Then it would have not collided. Okay, so now what that does is it guarantees that the animal being referred to in both of these objects, when derived, when inherited from in this fashion, the animal part, which is common to both of these structs, will be there will only be one copy. So this should compile, except for this diagram. This is called the diamond problem. Turns out that there's a name for it. If you look at the bottom, the diamond problem. Okay, explained by Björn Strostrup, the creator of C++. See, succeeded. Now how do we succeed at compiling? How do we know it's true? Well, what we could do is we could keep track of how much was eaten. Let's food amount be integer kilograms, could be units. kilograms consumed. Consumed. And we could eat a certain amount. Kilograms. And oops. And we can add that to what we have. We've already eaten, and initialize that to 0. Start out at 0. And hope that this constructor gets called. If there are constructors, well, there's a problem with constructors and this sort of thing too, but we'll get to that later. Okay, so let's say we eat 10, and then let's suppose that whenever we eat, our weight goes up or something. We point out our weight. All animals have weight. Right? New variable called weight. Now, I wouldn't want to initialize that to 0. That should probably be passed in the constructor. I'm going to start out with some kind of weight. Let's see how this works. Alright, now here we got, again, a problem. How are we going to initialize that weight? Let's see what the compiler says. You see what I mean by this being it's immediately a problem with everything. Even though there's this magic solution. Okay, now cannot make default constructor, can't be instantiated, neither can any of these things. These things need to initialize animals. Okay, so that means we need a constructor for a winged animal. Okay, a winged animal. I guess we'll have to have one that takes it into weight. Right? Alright, that problem is fixed. I do the same thing for mammal. Okay. What about bat? Which version of the weight constructor should be used for bat? That is, does it make sense to have a constructor here taking weight, right? Well, in fact, I think we're in luck here because I think these would be ignored. And what we need is we'll need to make another constructor to initialize the animal segment for our bat. And hopefully this will work. I think it will actually. Start a 1 kilogram bat. And it doesn't need 10 kilograms. Well, it's not kilograms, it's grams. 100 grams. 100 grams, 1,000 grams, and he eats 100 grams. So we change kgs to grams. Sorry. It probably looks okay. Grams consumed. Now, let's see now, no default. Winged animal, no default. Okay, we need a default. Now, why would we need a default? I don't know. Because I sure hope it's not going to use the default. Well, you can just declare it and not implement it. That way we'll get a linker error if anyone tries to use it. And we're getting a linker error. References bad. Oh, that's true. See, now as far as bad is concerned, it's true. It's bypassing this one as we requested, really. Okay, so we'll just put func. Okay, so it's not so bad, but you must be getting the feeling that we're going through a lot of work here to solve a problem that we invented ourselves. We invented this problem, and now we're trying to solve it. What we could do is just don't invent the problem. That's what I would do. If you don't invent the problem, then you don't have to fix it. No appropriate default for animals. Sorry. No, I think this one we could leave unimplemented. Because an animal's got to have weight. At some point, it's got to wind up on this one and not this one. All I wanted to do was, make it eat some grams, right? And have that alter its weight. I haven't even gotten to that part. Okay, now it will reference in this one that we're using for no reason whatsoever. Okay, well, we'll have to make it just do nothing. Put func. No, I don't know what's going to happen anymore. All I know is that my bat better start out at 1,000 grams. Now let's fix each here. Grams consumed is that, so that's how much we ate. And let's see, our weight goes up by some fraction of how much we consume. 20%. In grams. Like that, right? So our weight, after we eat, our weight should go up. And the flapping might make the weight go down, whatever. So here I want to go protest the back waves ground. Oh yeah, everything's in just regular, just debug. Do the same thing after eating. It should go up slightly. It should go up by 20 grams, right? So it should be 1,000 here and 1,020. Compared to 20. I shouldn't really need to go through all this. But I'm curious to see that it works. And I'm curious to see what gets printed out. Everything's got its put font. No, not this one. And not this one. So we used to fancy keywords, but in doing so, we had to add this function, this function, this function, and what else? Let's see, we had to add some extra functions. Okay, here goes. But you see the idea, what the problem is trying to solve. There's only one animal, and you derive from two things. That means you get a copy of, it's like having two different members, right? And you get a full one of each. And that we don't want that. Okay, so mammal void got called. Winged animal void. So those void ones got called, but animal void didn't get called, and that's good. I'm surprised that worked. Breathe flap. Mammal breathes. Winged animal flaps. That's good. That weighs 1,000 grams. We'll eat 100. Animal eat. What called? Okay, perfect. Worked perfectly. First time. I swear I haven't even tried this experiment before. Now, so that's the problem that virtual inheritance solves. And the problem in this server is, where was it here? Well, the problem starts here. Here there's a thing called a my interface, which derives from two different objects, okay? Something called a com base, something called an interface implementation, which implements the interface I my interface, okay? Now this here implements the com base stuff for a single threaded com object. So that should be query interface, add ref, and release, right? Okay. Now com base is defined here, and interface info is defined here. Now both of these things are com interfaces, turns out. They are, this person is called object root. Object roots. Object root has add and release. Those functions, those com functions, right? Though strangely not query interface. However, query interface is provided here. And this one doesn't have a query interface. This is just the com part. Oh, plus threading model. Okay, now the threading model has something to do with changing the reference counts, in which manner should they be changed, interlock or not. But the problem is both of these things are object roots, but there's only a single object, so there should only be a single object root in the struct, and so therefore he has to use virtual derivation. Now these things, well, these are not virtual functions as it turns out, so that's not a problem. However, there are virtual functions involved somewhere. Oh, these are virtuals, see? Object root itself. Standard method has virtual. Standard method info should not have virtual. Because I know it can't have virtual in it. Where is this defined? It can't have virtual in it because this is the thing that gets called from outside. This thing gets called through the dynamic dispatch, remember? So that's where its, if you like, vtable. Its vtable is in the DLL itself, and exposed to the outside world. So it's not part of the vtable of this C++ object. This doesn't have to be a C++ object. Okay, here it is. It's a type which has ulong standard method called type. God. Oh, no, not that. Oh, come on. You see it here? Here. There. Just standard call. See? Just a regular old function. The com functions are regular old functions, which you would expect. There's no vtable in the C++ sense, but there's a vtable in the calling the DLL sense. So although these don't have the virtual property in C++, they have a type of virtual property in the sense that depending on what interface pointer is used, a different class's version of these functions might get called. Okay? Okay, now back to our dilemma. What was the dilemma? The animals. Now, see, this works, but it's complicated, right? And nobody wants complicated. See, now the way I would do it, personally, is here we have a class called animal. Alright. Now, here there is something called a mammal. I would leave that just the way it was. Now, I don't need, well, I might need to wait, I guess. And that's an animal that has weight and it eats and it breathes. And this here, same thing. right? No virtual. Now, a bat is a winged mammal, right? So I would say that it's an animal uh, and so I would make it's a mammal, right? So what we need is a winged mammal, which is an animal that has wings. Mammal, sorry. And it has four flaps. That makes sense. It's a mammal that flaps its wings, right? Winged mammal, right? I don't see anything wrong yet, except we probably need to initialize the mammal section. The mammal needs an int. Okay. Now what's a bat? It's a winged mammal. You see, here, in these steps, without using any fancy keywords, we define bat. It's a mammal. It flaps its wings. It breathes and has a single animal, and there's no virtual blah 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 anything. There's no diamond problem, and there's no problem to solve. We get rid of this bat and get rid of the other stuff. So I wanted mammal. I don't need this winged animal. I might want it later on, but I only want winged mammals right now. So, okay. Oops. That I need a constructor. Turn up. It's derived linearly from this. There's no diamonds here, right? Just straightforward bat, winged mammal, animal. So we turn the diamond into a straight line. All this still applies. Should work exactly as before. Okay. The mammal, it's int constructor, what it's called, and that. Well, this one I don't have a footprint. Sorry. it should say winged mammal, well, bat, winged mammal, mammal, and then animal. Passing that number all the way down to the bottom. How much time have I used? Okay, I've used a lot of time, so this will just have to do for an insert before going on. And what I'd like to do actually is fix the other project so that we don't need to use virtual derivation. Okay, everything's fine. Breathe and flap. Okay, the mammal breathe and the winged mammal flap. That makes sense. The winged mammals flap. That's our weight. The animal ate, just as expected. And our weight's the same. Okay? Now this is what I call solving a problem by not inventing a problem to solve. It's true that we can do it both ways, but this way is simple. The memory layout is much simpler. We know at every point, we know exactly the memory layout of all the data. There's no data in these, but if there were, it would be in a linear fashion. We can cast this as any one of these things using a regular reinterpret cast, basically, almost. If we want to interpret this object as a mammal, we can just cast it that way, right? It is a mammal, right? Yeah, actually, just reinterpret cast should work for everything. And we didn't have to introduce the virtual keyword, and there are no virtual functions visible in the whole thing. And so this, solving the problem of multiple inheritance, which is tricky, etc., etc., by delegating to a sister class, so now we're going to invent a delegate, right, that does one part of something, and blah, 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 etc., etc., is maybe important in some scenarios, but in a simple scenario, like this, this is a simple scenario. We have two things, right, two objects. We have one object which is common to the two things, and we should be able to turn this into a linear inheritance structure and get rid of those funny keywords and not have the compiler start telling us lies because it can't, the debugger rather, because it can't figure out what kind of struct we're looking at. Alright, so till next time.